Yes. Okay.
Hello, everyone, and welcome to Conversations of Note. Um, I've just lost my questions here, so let me just see if I can bring those back up. Um, Ira and I are very fortunate today to have with us Jim Murray and George Wiseman, who are two experts on Brown's gas, Tesla technology, and free energy devices. Now, this is the first time George and Jim have appeared together to discuss these important topics, so it promises to be a very interesting conversation. I'm sure many of you are already familiar with George and know him as the inventor and producer of the world's best Brown's gas machine. George has also researched and produced information and equipment using Tesla technology and free energy devices. Our other guest is Jim Murray, who is an engineering consultant and independent researcher. He's been an investigator of Tesla technology for over 50 years and has worked with Yul Brown's gas technology for at least 3 years. Jim is a holder of numerous patents in the field of alternate energy technology and is also a student of the researches of Wilhelm Reich. Jim is also an enthusiast of Egyptology and the theory of lost civilizations. So, Jim, I wonder so that we can uh, get this conversation on the go, because this is really for you and George to exchange ideas, and for Ira and myself and the audience to sit back and enjoy. So, just to get it going, Jim, I wondered if you'd like to start the conversation with your views on free energy devices and the work of Tesla in this area. So over to you, Jim.
Well, first of all, I would like to mention that I find the term free energy inaccurate because, from one perspective, all energy is free. And from another point of view, you got to pay for all of it. And so it really doesn't tell you what you're actually striving to achieve. I prefer a gain and work function, which is really Tesla's point of view and my own after a number of years of considerable research in this area. And so I guess that automatically propels us into the realm of Tesla technology. And I started into that area as a very young guy. My initial interest, which brought me to Tesla, was particle accelerators. And I had won numerous awards for designing particle accelerators in high school. I even I even had some of my units on display in the Boston Museum of Science back in the early 60s, and I won all kinds of awards and stuff on that. But that's where I came into association with Tesla because he was accelerating particles himself, although most of the time it was for a different objective. That's a whole story in itself. But once I got interested in him and I started to investigate him more deeply, I was very lucky because I was born and raised in Jersey City, New Jersey, and it was only a subway ride across the river to 42nd Street. And I had access to the main public library, which was only a short distance from where Tesla used to hang out. And so they had copious articles on microfilm and actual other storage medium that I was privileged to access. And I had an enormous file on Tesla and read through a lot of things, and that opened my eyes to his way of thinking because somehow I could just read between the lines and I knew what he meant when he said certain things, even though they were sort of clashing with classical points of view. Didn't bother me. And so I just went ahead and followed my instincts. And that brought me into a whole different realm at a very early age.
Okay. Um, would you like to sort of elaborate on some of the things that you started to discover whilst reading through some of those papers? I know that that would be a mammoth task, but just to give us some tidbits of that.
Well, I don't mind doing that, but I can tell you, I kind of agree with George. If we go down that rabbit hole, it's going to be an extensive underground adventure. But anyway, yeah, one of the earliest things that really inspired me um, was an article, and I forget exactly which periodical it was. It was either in Century Magazine or an Electrical Experimenter, which were two of the publications that carried a lot of his earlier releases. But he had this amazing article about the rotation of the moon. And of course, prior to reading that article, I was under the impression that Tesla was more or less focusing on electromagnetics, electrostatics, and things of that nature. And so to see this amazing two-part article on the orbital characteristics of the moon, equipped, I might add, with a whole series of rather involved mathematics, it really made me wonder why in the world he would place so much emphasis on this particular exposure and how did that fit in with all of the stuff that he was doing. And like I said, it's going to be a real departure from the main thrust of this thing if we get into that. But suffice to say that the message I got out of it after a lot of distilling uh, is the importance of relativistic reference frames in all of this work. And basically, it reappears even in magnetics and electrostatics, but uh, it's disguised, you might say, in other parameters which are just taken for granted to be curiosities particular to those fields of endeavor. And once I had a few of these things under my belt, I started duplicating some of Tesla's experiments using my point of view or Tesla's point of view. And that's when I started getting some really unusual results. And I think maybe George uh, might have some similar stories to tell because there's no way that you can dabble in Brown's gas and the theories behind it without winding up in a similar location. It's just the way it is. Everything's connected in the universe, you know.
Well, perhaps you'd like to come in on that, George, and uh, give us some of your wisdom.
First of all, Jim and I are, I think I'm totally agreeing with Jim. There's a lot of things that are misnamed out there and they provide the wrong perspective when you're looking at the particular names of whatever's going on. And unfortunately, that's just the way it is. I give an example of a light switch. I call a light switch an over unity machine. Similar to what Jim is saying is you're controlling an energy flow. You get this much energy expended and you get that much energy out kind of thing. So when I'm being an inventor and looking for alternative energy and what we're going to call free energy, and I call free energy, I define it as you don't pay somebody for it. You'll pay for equipment to put in place. It probably even cost you more money as far as that goes. Even putting solar panels on your roof or any of those kind of things. But the point is you don't pay a utility for it. So that's what I'm calling free energy, just to clarify the semantics in my thing. So I'm always looking for energy flows or energy hills and then build a device to tap into that. Just like a person with Niagara Falls, you build a turbine and attach it to a generator, you attach it into the energy flow of the falling water. And there's so many energy hills out there that maybe one of the simplest is the ambient electromagnetic energy that's fluctuating all the time. And I was given an award for a very small device that I made. I called a free energy receiver back in the 1990s. because I was able to show that with no energy input whatsoever, this thing just kept charging capacitors, and then you could use the voltage, amperage and voltage it was charging the capacitors just from ambient electromagnetic energy. And Tesla did similar things himself, where he put up a large panel that could collect electrons and stuff in the air and compare it to the ground. And there's quite a bit of voltage difference. Again, you're looking for energy hills between the surface of the Earth and the upper atmosphere the farther you go up. So we definitely have the technology, and it's been suppressed. That's also very much proven. To have free, what I call free energy. You're not paying for it. You put devices in every home or in every neighborhood that would gather ambient energy of various kinds and power everything without paying a utility. So I think that I'm totally agreeing with Jim about the definition and also of where you can person look. A little of my history quickly. I was actually the opposite of Jim. I had no access to all of this wonderful information from the past when I was growing up on a cattle ranch in the middle of British Columbia, Canada. We were so far out in the woods, we didn't even get radio. And Dad didn't want to buy batteries or anything. There was no electricity, no running water, no any of that stuff. We lived in a trapper's cabin that was built in the 1800s. So but we did have enough things around to fix things and stuff. And I had a 1966 Ford pickup truck that my dad bought me so I could drive into town to go to school. And I fixed it up the best I could, just having my innate knowing how things should work. I understand how Jim is on that, where some things just make sense and you can read between the lines. So I wasn't traditionally trained as a mechanic, but I started this. I actually started my business because that 66 Ford pickup truck was getting 36 miles to the gallon. And I didn't know that a pickup truck wasn't supposed to get 36 miles to the gallon, but I did it because I just put it together the way that I thought it should be done. Turns out I can actually get now in the range of 400 miles to the gallon with the technology that I know now, but that was when I was a kid going to high school. So I started my business, Eagle Research, with the fuel saving aspect of it. And there's a lot of different kinds of fuel savers, and they work just fine. There were a lot of scams out there, and it was unfortunate about that. I was investigated by various government agencies in the United States and Canada 7 times, but they were never able to find an unhappy customer. So those investigations went nowhere. But there's a lot of suppression on free energy, what I'm calling free energy, and fuel savers. So I definitely saw behind the curtain quite a lot back in those days, and that helped me negotiate this most recent idiocy where they were doing this pandemic stuff. Anyway, so that's a bit of my history as far as that goes. I got into Brown's gas, which, by the way, I'm inhaling Brown's gas, not oxygen here. Every time I sit down at the computer, I'm putting on my cannulas. And unfortunately, that often means I get 8 hours plus a day inhaling. But I really appreciate what it's done for me. And if anyone's interested, I can send them to a website that shows my story as far as the Brown's gas goes. But quick is that I was using Brown's gas as a fuel saver at first because it increases the efficiency of carbon fuel combustion by lowering the endothermic energy. In other words, it breaks apart the carbon and hydrogen bonds easier, like a catalyst, therefore allowing more exothermic energy. And our internal combustion engines are heat engines, so the more heat that you can put to the engine, the farther you're going to go on a gallon of gas. So the Brown's gas was one of the fuel saving techniques that even works on today's automobiles, not like the carburetors I was working on back then, but fuel injection and stuff. And the longer the hydrocarbon chain, the more this effect helps. There was an article online. I did copy it because it got taken offline, where they were ocean-going ships, which essentially use crude oil. So it's very long hydrocarbon chains, were doubling their mileage, doubling how far they could go with the ship. So almost doubling, 90%, excuse me, increase in economy. which is pretty phenomenal. Diesel engines, the large trucks on the road, we're getting about a 50% increase. And then with the lower carbon chains like gasoline, we're getting about a 25% increase. And that kind of thing can still be done. So I agree that but getting back to it, we got to talk about clarify what it is that the people are expecting and what we're talking about. There are some misconceptions out there. For example, earlier in a conversation, we were talking about Brown's gas and its implosiveness. There is an implosive portion of Brown's gas. So just to define Brown's gas as I define it, it's the entire explosive collection of gases that are generated from a Brown's gas electrolyzer. Those include 6 different constituents, all combinations of hydrogen and oxygen. So in the end, you still have 2 parts hydrogen to every 1 part oxygen. So we have your diatomic hydrogen, your diatomic oxygen, so H2O2. You do have a very small amount of H and O, which shouldn't exist, but it does. So you've got monatomic hydrogen and oxygen. And then you have regular water vapor, which is anytime you have water, you're going to have water vapor. So it's H2O as water vapor, or you could call it steam if it's but a low temperature. And then the final thing, which defines Brown's gas against what I call oxyhydrogen, which is a diatomic mixture of, a 2-to-1 mixture of hydrogen, diatomic hydrogen, and diatomic oxygen. And if you have an electrolyzer that's not designed to make Brown's gas, like the ones that use SPE or membranes or PEM membranes, or if you have any membrane in the middle, even if you're using a traditional Faraday electrolyzer and you have a membrane in the middle, so you have your hydrogen coming out one side and your oxygen coming out the other, you do not make Brown's gas because you don't make this thing that I call electrically expanded water. And it turns out that when you have no membrane, as the electrons are flowing across from the cathode to the anode, it makes what we call an electron bridge. And somehow, as the electrons are forming across this bridge, flowing across this bridge, some electrons get sucked up by water. Water soaks up electrons like a sponge soaks up water. And the resulting gas, water gas, is a cold plasma form of water. So negatively charged plasma that's essentially room temperature. And this high energy gas I call electrically expanded water, or EXW for short. And that's what makes Brown's gas unique and more therapeutic, but also more effective for increasing the efficiency of combustion of carbon-based fuels and several other things as well. Like if you're using it as a torch to increase or to cut steel, it cuts steel 30% faster than acetylene, because it increases the oxidation rate having to do with those extra electrons. It's all about those extra electrons. So Jim is worked with Yule Brown. Yule Brown tried to sue me, and that went sideways. Nothing ever came of it because I wrote Brown's Gas Book 1, and he was trying really hard to control the narrative having to do with Brown's gas. He was a very intelligent man, and he was his own worst enemy, which a lot of us are, as far as that goes. And he spent a lot of time and money, millions of dollars, I think, in the end, trying to control and be the only person having to do with Brown's gas. It was unfortunate as far as that goes. I never actually got to meet him in person, but we did speak and communicate somewhat. So I think it would have been so much better if people like us would be able to collaborate and share ideas and work things out experimentally, which is what I ended up doing as I developed myself as an inventor. There were lots of things that I could see that worked in my experiments, but I couldn't explain them. I didn't have the math or the physics knowledge or chemistry or whatever, but I did it an Edison way, if you will, because Edison and Tesla had 2 different ways of inventing things. Tesla would figure things out in his head, and by the time he would build them, they would just work the way he envisioned them. Edison would, like when he said he was inventing the light bulb, he found, what was it, 4,000 different ways not to do it. Just bulk inventing. And unfortunately, I try to do Tesla as much as I can, but unfortunately, it's more Edison I just try things and find out what doesn't work, and then try to figure out why it didn't work, and then build something that theoretically doesn't have that problem. And then I'm working on a gravity wheel right now. I think I'm close. But gravity theoretically, in my opinion, is an energy flow. So all we got to do is make a machine that can fit in there. Unfortunately, it's kind of a lean energy flow. You can only just get a few watts of power out of a fairly large machine. So I don't know how much it would benefit at this time. I'm just trying to prove that it's possible. But if you spend $1 million to get a machine that puts out 5 or 6 watts, that's not cost effective. Lots of other ways you can get your energy instead of that. So that's my introduction as far as it goes.
Okay, well, thank you for that. Can I just ask a question? Because I'd said about the peculiarities of Brown's gas, and you were mentioning about this the coal plasma. This, I know you've spoken it as a bioavailable electrons, which is what we inhale. But I think this, if I'm correct me if I'm wrong, using the gas torch, using Brown's gas, it really sort of burns what you might call a cool flame, something like 130 degrees centigrade, which is quite cool for a burner. And but even at that temperature, it can still cut tungsten, which am I right in saying that? Which is quite peculiar, really.
You are absolutely correct. The Brown's gas radiates at about 130 degrees Celsius. But if you apply the gas, it's interesting. It hardly boils water. Like you put it in a glass of water, the flame in a glass of water, and it'll take a long time for the water to even get warm. But you take and put it against the glass or the side of the container holding the water, and it'll burn right through it. It'll burn right through space shuttle ceramic. Anything, it's almost like the more resistance something has to being burned through or heat related, the faster the Brown's gas will burn through it. It's more an energy flame, like an electrical flame, rather than a thermal flame. So it doesn't preheat steel as fast as acetylene does, for example, but once you start cutting, it'll cut it a lot faster. So a lot of it has to do with the material you're directing the flame against. The flame itself never changes temperature, but the material itself reacts differently depending on how it's affected with the electrons. So water hardly heats up, but tungsten will heat white hot in less than a second. It'll just make a white hot spot and start burning through. There's several practical applications of that. And I did skip over the one part where earlier you were talking about the implosive mixture is the electrically expanded water. The implosive part of Brown's gas is the electrically expanded water. Now that's also confused with the overall implosive mixture of the Brown's gas, but the Brown's gas will explode first because the flame is mostly a normal hydrogen-oxygen flame. But it contains this constituent that if you were able to separate it out, which I haven't been able to do yet, this electrically expanded water, as soon as it loses electrons, it goes back to water. So it expands 1,800 times going into this state of electrically expanded water. And once it loses its electrons, it goes back to liquid or steam or liquid, whatever, water, and contracts. And that makes a vacuum. So if you have Brown's gas in a container, in a contained area, and you ignite it, it will explode. I have lots of videos of that. And it will, and actually a shock wave will shatter glass. I just made a similar one, even at ambient pressures, like ordinary atmospheric pressure. The shock wave itself will shatter the glass, kind of like an opera singer, the glass is fragile. That's one of the reasons we use plastic containers, because the plastic can expand, it won't shatter. But then if it's in the enclosed area and the enclosure doesn't explode, it's contained, then it'll make a vacuum. So also, if you're burning it in open air, it makes a tunnel in the air. So as it's coming out, it burns in open air at about 21 feet per second. So if the gas is coming out of the orifice faster than 21 feet per second, it won't burn back into the orifice. That's called a flashback or a backfire. And it'll come out very laser-like. And the reason it's a laser-like flame is because it's actually making a vacuum. It's doing exactly what I just talked about, where it's taking the hydrogen, oxygen as gases, 1,800 times expanded, and contracting. The exhaust of a Brown's gas flame is water. And so it's contracting into water, and it's making a tunnel, a vacuum tunnel in the air. And the air pressure itself is holding it in this long, thin flame. And then it comes to, we could be also talking about what the Brown's gas water is, like the water that's condensed is what I call new water. It happens to be deuterium deleted water. I call it deleted instead of depleted because no one's been able to measure any deuterium in this exhaust water from the Brown's gas flame yet. And and it's new water, which can transmute into other aspects. So that's a lot of things to have to do with Brown's gas. Again, we can go down different rabbit holes. And then getting back to the Tesla technology, I had researched several of the different aspects of Tesla technology. It's almost like my mentor as well. Like Jim could certainly understand that. And I have a lot of quotes and stuff from him, but and the Tesla turbine as well. I did quite a bit of work on figuring out how it works. And one of the things I really appreciate about Tesla, and I'm not going to quote this exactly, but in the general idea, he says, I work so hard to make things simple. Why complicate it? Because everybody who grabs one of these technologies starts figuring out they could do it better. And it doesn't work as well. As I found when I'm inventing, I'll usually start with some sort of a Rube Goldberg type apparatus that gets the job done. But then as I learn more, I start chopping off things that were extraneous and not needed until I get down to the very simplest essence of what it is. So if you can't build it simple, you don't understand it yet. And Tesla really could build things simple. I really appreciate that.
Okay. George, can I jump in and ask a question here? We're trying to find out what the magic is in Brown's gas. So my first question is, how do you measure that? How do you know that Brown's gas is Brown's gas? And secondly, all this talk, actually I pulled out an article that you had on your website by Moray King about the 0 point energy. Do you remember that article?
I do.
Okay. Well, Jim and I both know Moray, or knew Moray when he was in the Psychotronics Association. But to me, his 0 point energy is the same thing as Wilhelm Reich's orgone energy. So my question is this: when you are creating Brown's gas, you're separating the hydrogen and the oxygen, but then the magic happens. Is it possible that since water is matter, that you're actually deconstructing water and bringing it back to the 0 point energy, or what we would call orgone energy, which would be mass free, and that might account for the low temperature and the vacuum you were just talking about with the laser. So those are the two questions. Can you measure what Brown's gas is? How do you do it? And then is it possible that you're deconstructing the water somehow, and that's where the magic is? Because Reich also believed that orgone energy manifested itself as negative electrons.
Well, I can touch on only part of that. When I was really interested in the Brown's gas phenomenon and had the wherewithal to pursue it, we're talking quite a few years back, I linked up with a gentleman who was a physical chemist, and he had an awful lot of connections in various institutions and universities. And I believe we went to the University of, it was one of the big ones in Ohio, I forget which city. And we brought with us one of the miniature Brown's gas generators that was actually supplied to me by Brown through the Chinese company that he was working with for many years in Mongolia. And it's a pretty small but very powerful unit. And it was already set to go. We plugged it in, and this other gentleman hooked it up to a gas spectrometer. And we introduced the gas and let the system purge. And then when he turned on the equipment and actually did the analysis, what was fascinating was the output reported that it was essentially water. It didn't read anything else. It didn't even read hydrogen and oxygen. However, the water was phase shifted. And I really don't know exactly what that means, except for the fact that there was a completely different arrangement between the locations of the hydrogen and oxygen atoms in whatever this gas was. And this gentleman that I was with believed it was HHO, which is what Professor Brown had suggested. Then, of course, I got really involved. I was actually invited to go to Japan and work with Professor Osama or Omasa or whatever his name was, the guy that you just gave me the paper on, Ira, the other day.
Yeah.
And interestingly enough, he was laboring to try and compress Brown's gas because initially in its pure state, it behaves like a solid, or actually behaves like water. It's non-compressible. And so there were a lot of interesting mysteries. But the thing that really impressed me the most, and which I have done the most work on, actually, was twofold. One was the implosion aspect of it, and the other was the cutting and the welding portion of it. And when I was working with Brown, he told me that there was a trick in the preparation of the electrodes that are involved that had to do with the RMS finish of the electrodes, from the machining point of view, had to have a certain finish on them in order to achieve the type of yield of pure HHO that he was after. And my interest was actually more in the implosion than anything else. And the curious thing about the machine that I was working with, which cost me about $1,500 back then, and it was small enough to be portable, but it weighed about 85 pounds. So it wasn't a tiny outfit. But the output from that machine, if you used that gas as it was generated to displace water from a known volume, then the mixture or the compound or whatever you want to refer to it as that was left always imploded. It wasn't a question of maybe or partially or in two stages or whatever. It always imploded. So there was something very different about it. And I actually built an atmospheric engine based on that principle. And that took quite a few months to do that. And we also had a very intriguing demonstration where I took a large hydraulic cylinder and prepared it in a certain way and used that as part of a lifting apparatus. And then we would take people from the audience and actually sit them in a chair and charge this cylinder with Brown's gas and cause it to implode. And you could see it immediately create a vacuum. The pressure in the cylinder goes to zero. And then as you open the valve and let air into the one end of this piston, it would lift as fast as you wanted it to until the vacuum was depleted. And we used to get the heaviest people from the audience and give them this 4 or 5 foot ride on a hydraulic cylinder. But the engine was designed to be continuous. And the interesting thing about it was the amount of power that it took to displace the atmosphere from the piston was pretty much volumetric in nature. But because of the nature of the circle, if you had if you have a larger piston, you're obviously getting a larger yield because the atmospheric pressure is 14.7 pounds per square inch. And the bigger you make the piston, the more force is available. And the ratio of the available working force versus the expenditure to create that volume of Brown's gas was very significant. And so, unfortunately, a lot of that stuff never went anywhere because it was very difficult to raise money for anything like that. And as a matter of fact, getting back to the anecdote that I mentioned earlier, where we were in the university in Ohio doing that experiment, we were lucky that we actually finished it before anybody came in, because one of the technicians came into the into the room and said, "Oh, what are you doing?" And this other gentleman explained to him that we were analyzing a very special mixture of hydrogen and oxygen. And it's unfortunate that he used that word mixture, because as soon as he did that, this guy set off alarms and got security and threw us out of the building because he said we were playing around with something that was potentially very violently explosive. And the fact of the matter is, everything I ever did with the Brown's gas, I never had any problem with anything exploding. And as far as the flame is concerned, I did a lot of work with the flame. And one of the things that, and I sort of agree with what George was saying about the nature of the flame, we measured hypersonic velocities in the flame front. And the interesting thing is, if you look at it through certain filters, you can actually see a continuous succession throughout the nature of the flame of little V-shaped disturbances. And this other gentleman, who is a physical chemist, suggested that those influences in the flame were suggestive of hypersonic velocities. And so that in itself is very interesting. And then, of course, Professor Brown did some things which I was never in the position to do. And one of them was he used flame spreaders and then exposed various radioisotopes to Brown's gas. And the radioactivity was greatly reduced, which suggests some kind of a transmutation or a similar effect. And the thing with this other guy that resonated along those lines was his insistence that there was, or would have to be, I don't know that we ever measured it, a very intense neutron flux associated with this. And if George's theory is correct about the difference between protium and deuterium being involved here, you know, if you subtract a neutron from deuterium, you're going to get ordinary hydrogen. So it's possible that there's some kind of a transmutational effect associated with all this. And I'm a pretty practical person. So, you know, when I bang my head against the wall, after about 200 bangs and a lot of lumps, I decide that maybe changing direction is appropriate. And so, especially after Brown died, I had other things to do. And so I did move along, but I never lost interest in the basic effect. And I think there's a lot there that needs to be understood in great detail. So
Jim, I was asking the same question, Jim, that I did to George, if you can both discuss it. Is it possible that you are deconstructing matter when you're creating Brown's gas? For instance, like when you cut through tungsten, you know, we're thinking about heat, you know, being generated, even though it's very cool. How can that possibly happen? Is it
well,
possible?
that's not correct. Okay. No, absolutely not. I can tell you that we did temperature experiments and under the direction of Professor Brown himself. And what Well, of course, he was using Fahrenheit measurements at the time, but 212 degrees is the boiling point of water. And that's what the flame burns in normal air. You can run your fingers through it as long as you don't keep them there and without any ill effect whatsoever. And yet, when you relocate that flame to a different target that has a higher atomic number, the temperature immediately increases. And what's interesting is we vaporized tungsten at over 6,000 degrees instantly with that flame from his little generators. And that prompted him to relate some interesting stories to me about what was going on in some of the research that was done up in Mongolia on the Mongolian Metals Institute, where I think he was a guest of them for several years before going, I forget where all he went, but he wound up in California eventually. And one of the things he was saying was that the Chinese or the Mongolians, whoever he was working with, they had a system set up where they were injecting tungsten wire into a Brown's gas flame on a controlled rate to increase the velocity of the wire. And the temperature that was liberated was in excess of 6,000 degrees. And then that was used to create superheated steam and run the generator and give the electricity output, which of course was far greater than what it took to create the Brown's gas in the first place. And so he was very intrigued with that whole situation. And apparently they were very generous with him and very appreciative of his knowledge. And that all stopped when they asked him to help him build a weapon. And he did confide to me some aspects of what that weapon was about. And I'm not going to get into it because it's pretty horrific. And what they had in mind to do with it was not beneficial either. But all the other aspects of it are pretty amazing. And as I mentioned, I think that they're very well worth pursuing. The only company that I know of that ever did anything with some of that stuff on a much more detailed level, and they did have an incredible amount of funding, was a company called Blacklight Power, which was actually centered in New Jersey, of all places, since that's my home state. And I have no idea what they're up to now, or even if they still exist, but they were talking about accessing energy from hydrogen that was actually below the normal state. And I tried to find out what the normal state was, and they were defining it as the covalent energy associated with the bonding of H to H or H2. So by breaking that bond, they were accessing excess energy, and they associated that with a process similar to Brown's gas, which is very interesting. Because according to Brown, if you do all this correctly, you won't get anything but HHO. And one final note that I'm going to throw out there, which is very interesting. I asked Brown personally if he would be kind enough to tell me where he got the introduction to this concept. And of course, I knew him as a kind of a physics guy. I don't know too much about his educational background, but it turned out that he was actually a monk in Bulgaria for a while. And he was assisting in the categorizing of various ancient books and manuscripts. And he came across one that was called Water from Fire or Fire from Water or something like that, which was actually an alchemical document. And he translated that. And I don't know what happened to the original document, but that's where he got his introduction to this process. And he said the most important thing in the preparation of the gas, besides the electrode surfaces and the spacing between the electrodes, was the volume of the combining chamber, which is what he called the collection dome above the electrolysis elements themselves. And of course, all of that registered in my head, but I never had a chance to really get into it any further than what I've already described. So at that point, I think George is the reigning expert in this type of thing. But I had enough experience to know what's valuable from my point of view. And someday, God willing, I'd like to continue on with that. So that's all I got to say, really.
Okay. First of all, the electrode, just to feedback on some of these things, the electrode finish is important in my experience. Okay, let's just back up one step. When I was doing electrolysis at first, regular Faraday electrolysis, it was coming in at about 14 watt hours per liter of gas produced, okay, at standard atmospheric pressure and temperature. So and Yul Brown's machines that he was making in China at the time were and was being sold by Dennis Lee were coming in at around 7 watt hours per liter. So twice as efficient as normal electrolysis. My experiment.
Excuse me, can I ask you a quick question? You
Sure.
can get back to it. Is that company still available for getting those Mongolian-made gas generators, or are they
I
out of
don't
business?
know if they themselves, but there are many Chinese companies making Brown's gas or HHO electrolyzers now, and a reasonably good version. Like I'm buying a chassis for my AquaCure from China for like $150 per on these machines, and I can't even get the materials, let alone do all the machining and everything to make the hood and all the various stuff for $150 in America. So I'm able to get this chassis, which then I rebuild using my technology to the best I can. There's only a certain amount you can do with something that already exists when it's not optimized. So I don't know if the BN machines, and I have one in my warehouse somewhere, similar to what you're talking about. I think it was the 85-pound small machine. Those were very well designed. Unfortunately, they just one second here. Unfortunately, they aren't able to I got distracted there for a second. They're very well designed, but unfortunately, the materials they used weren't very good. The metal, for example, the frame on it, you could bend with your hands, the metal frame. So, but it was a well-designed machine. It didn't have optimized plate spacing. It was way too narrow, which again, you were talking about the plate spacing versus the electrode finish. If you had little points, it worked out better. But because the gas would get off the points, and because any spot on that there was a bubble of gas became a non-functional piece of the surface of the electrode. So, and any gas generated at the bottom of the electrode, as it sticks to the electrode, the bubbles stick to the electrode and go up, it makes the whole electrode surface full of bubbles, and you get a poor efficiency of electrolysis. The other thing having to do with the Brown's gas was the plate spacing, very, very important. Had to do with a lot had to do with the frequency of the electricity pulsing into the machine, and it had to be pulsed DC. You can't have just straight DC. So you have pulsed DC, and at a certain frequency, you'd have a certain plate distance, but then it also made a difference as to which catalyst you were using and the density of the catalyst, and there was a whole lot of variables. So I worked my variables down to the point where I had an electrolyzer that was producing 1 watt hour for each liter of gas. Actually less than. It was 0.9 watt hours to make a liter of gas. So highly efficient electrolysis. But a large part of it happened to be making this electrically expanded water rather than just the H2 and O2. So the H2 and O2 are still a significant portion of the gas, but this EXW was why I was getting now over unity. And there's no such thing as over unity. It's always everything balances in the universe. But if you measured the electrical input, the amperage going through the machine, it's amperage that makes the gas that splits water into hydrogen and oxygen. If you measure the amperage going through the machine, you end up with more, and compared to the Faraday laws, I was getting 30% more gas than I should. And this comes back to the measuring of Brown's gas. I knew I was making something unique because in this gas mixture, because I was using a lot less electricity than significantly less electricity than I should to make the volume of gas that I was making. And this was duplicatable all over the place. If you built the machines to my specifications, you got this result 100% of the time. So I first theorized that it was making monatomic gas, H and O, and that was making up the volume. But when we got spectrographic analysis done, we discovered that there was very little H and O. There was some, and this comes back to Yul Brown calling it a fluid crystal, called it a fluid crystal at some point. And I think that that's the case. The reason there can be monatomic atoms, if you will, in the mixture is because there's some structure holding them from combining, the H and H forming into H2. There's something that prevents them from doing that. And they really want to do that. So there's something unique about the Brown's gas mixture that prevents that. So the electrode finish is important because if you have little points, the gas bubbles come off the plate easier. But I discovered an even better, a more efficient way is what I call a grid plate. So as far as that goes, and then the plate spacing was really important. So I said, okay, we'll use 50, 60 hertz full wave rectified. So we have 120 pulses per second, which is very much close to what the Omasa stuff was doing, as I recall. And then found the optimal plate spacing with the optimal electrolyte density. And that's where we ended up with the design that was making using less than a watt hour to make a liter of gas. So then we have what I call Brown's gas that we're trying to measure, and we're finding it very difficult to measure the electrically expanded water portion of the gas. There aren't any machines that can measure that. When we do the spectrographic analysis, just like Jim said, it shows up as water. And yet we had dried the gas. We put it through desiccants and stuff, so there was 0% humidity going into the spectrographic machine, and yet it was still showing water. It was less water.
Did you get a phase shift reading as well? And I'd like to know what that means.
Yes, I don't know anything about the phase shift. That was new to me when you were talking about it. So then there's other effects like magnetism. We can't feel it, but we can measure it because it affects things. We can with the Brown's gas, for example, easy gel or easy water. Are you familiar with Joe Pollack's work? All of you?
Yep.
Yes, good. All right. So when you have easy gel, when you have a hydrophilic surface in water, it automatically forms the H3O2 negative gel against the surface of the hydrophilic surface. And everything in our bodies is hydrophilic, which is one of the reasons why this is working so well. That's a whole nother thing I get into. But the point here is if you put hydrogen in the water, the easy gel does not increase. If you put oxygen in the water, easy gel does not increase very much, a little tiny bit. If you put hydrogen and oxygen in the water, like oxyhydrogen mixture, again, you just get a little bit of increase. If you put the Brown's gas in the water, you get a minimum of 3 times increase and up to thousands of times increase in the thickness of the easy gel. So obviously Brown's gas is different from the oxyhydrogen based on these kind of experiments that we've been doing with Gerald Pollack and others. So I just wanted to put in my perspective in those things. I think the stuff.
Do you have an answer for that, George? I mean, why is it about the Brown's gas that causes that increase?
Yes, it has to do with the electrons in the electrically expanded water. So you have water that has a whole bunch of extra electrons attached to it or in it or absorbed in it. And as it gives up those electrons to the H3O2 negative, because that's what happens is you can actually make a water battery using just pure water and this hydrophilic material, because there's a voltage difference that occurs. You end up with a lot of positive out in the actual mixture, and the negatives, electrons, are fixing themselves to the surface in the gel. So the more of the electrons that you have out in the mixture originally, the thicker the EZ gel is going to be, can be, because it's H3O2 negative. It's got a negative charge.
Is that what you were calling I think you were calling it the water clusters? Is that?
I don't call it water clusters. There are such things as water clusters, and they've been measured by various people. I'm no expert in that, but the gel itself is just a gel on the surface of the material.
Well, a cluster, if I may interrupt, is usually defined, at least in the alchemical sense, as the smallest amount of nuclear material that you can have and still retain the known properties of what you started with. And if you get a microcluster that's smaller than that, it changes entirely in its behavior and its composition to something else.
So is that what Omasa was talking about when he was talking about the nano clusters?
Yeah, I believe so. But then again, that was a long time ago when I was in Japan, and I don't even know if that gentleman is still alive. Unfortunately, the guy
is gone.
Pardon me?
I'm sorry. Omasa is dead as far as I know.
Oh, is he? I'm sorry to hear that. He was quite brilliant.
Just a couple years ago.
Unfortunately, the gentleman that introduced me to him is also departed. He was another fine guy. And so, here we are struggling in a very complicated universe, looking for like-minded spirits or kindred spirits, to pursue the same goals. It's kind of lonely sometimes, but such is life.
Well, George, I did some fundamental experiments. I bought this is the device. It's only like $50, but supposedly measures hydrogen and ORP meters, whatever. And I have the device, which just the hydrogen water device, and of course your device. When I measured them, I didn't see any difference at all in the ORPs or in the amount of hydrogen. So if somebody like myself, an innocent, came along and said, well, why shouldn't I drink this? Which only costs $200 versus a $2,500 machine because I'm getting this same amount of electrons. What would be your answer?
I'd say that something's wrong with the measurements.
Really?
You should be getting less hydrogen in the Brown's gas bubbled water. So you have a container of water that's bubbling the Brown's gas in it. It's not going to have as much hydrogen in it as that water bottle makes for hydrogen-rich water.
The number is, and it's pretty consistent. Maybe something is the matter, but it's about 3,800 parts per billion that I'm getting in Brown's gas as well as this. It also measures some parts per million, but I was looking at parts per billion.
Yeah, but these people that go with their parts per billion, it's just a marketing thing.
Okay.
Whenever I hear that, my eyes roll. So I stick with the parts per million. Those water bottles, if you bring them under pressure, you can put more gas in the interstitial spaces in between the water molecules. You can't see the gas, but at higher pressure, you can put in more gas. As soon as you release the pressure, just like carbon dioxide enriched water, that gas is going to start to be released. So if you could just have ambient pressure, I think it's 1.6 parts per million hydrogen can fit into water. You can get more oxygen in there, but when you have the combination of hydrogen and oxygen trying to go into the water, then you get into the gas laws of partial pressures and such, and essentially the oxygen takes up some of the room that the hydrogen would have been.
Yeah.
So you're not going to have, with Brown's gases, you're not going to have as much hydrogen in there by about 25 or 30%, if I remember the measurements. And the measurements we had to use to get this were $2,500 machines that they made for the nuclear industry, because they were designed so they could ignore the oxygen, for example, and only measure the hydrogen. So what you're measuring with that pH ORP meter is essentially electrons. It measures in millivolts, and it implies or it thinks it's a certain amount because they take certain things for granted. But as soon as you change the parameters, like put in the oxygen, well, then that thing's going to be incorrect. Now you
Uh,
can still measure pH, potential of hydrogen, which interestingly enough, hydrogen itself is pH neutral. Adding hydrogen to water doesn't change its pH very much, but electrons added to the water do change the pH, potential of hydrogen. So you are going to measure a slight rise in pH. You will measure the rise in ORP, but you're going to have to be doing it, and for lack of a better word, I'm going to have to say it correctly. We could probably work out a system. I need to make some videos on this where I can show people how to and why, and that it does be different. I have a document that I put out having to do with the ORP, where a person took an AquaCure and a 3,000 liter per milliliter per hour, three per minute, excuse me, 3 liters per minute machine against the Brown's gas, which is only about 500 milliliters per minute of hydrogen. It's about 800 milliliters per minute when you add 833 when you have both the hydrogen and oxygen at the whole Brown's gas mixture. But essentially, 6 to 1 as far as the hydrogen is concerned. And when you took this Chinese machine that was making oxyhydrogen and compared it with the Brown's gas machine, the ORP dropped like a rock with the Brown's gas, and just kind of gently went down with the so you have to measure over time as well with this particular thing in order to get the inference. And so it went down like this and then across like this with the 100% Brown's gas. 40% Brown's gas kind of went like this, but the oxyhydrogen just kind of went like this, but never went quite as low as the Brown's gas goes as far as ORP.
right.
But eventually it gets down there. But it was putting in 6 times more hydrogen to do the job, or 3 times more, a little more than 3 times more gas volume to eventually get down there. And I forget what it was in the minutes or in the chart. I'd have to go back and look at it. Again, like Jim, over time, some things just kind of get lost and you have to review.
Well, in other discussions we've had, when you were talking about in terms of health, okay, you're saying that hydrogen is like the most important nutrient, that we have. If I'm understanding you correctly, you also said that the electrons that are produced in the Brown's gas are the things that actually help deliver the hydrogen to the muscles and the tissue. Is that correct?
That's correct. There's three
Right.
things you need for healing, for health. You need your nutrition, which is not only hydrogen, but all the other micronutrients as well. Obviously, oxygen in order to do and you need energy, because like a pile of bricks doesn't just spontaneously form into a brick house. You need, and the third thing you need is intelligence. The body has the intelligence if it has the energy and nutrition in order to heal and be as healthy as you can.
And is the energy part the electrons?
So the energy part is the electrons. And the nice thing about the Brown's gas is you're putting the electrons right into your bloodstream, bypassing all your normal energy generation systems. When people get sick, generally they've used up their energy reserves, and their energy generation systems have been compromised in one way or another. So
Right.
that's one reason why the Brown's gas is proving to be about 30% more therapeutically effective over just oxyhydrogen because of the extra electrons. Now you can get extra electrons a lot of different ways. You can use TENS machines, you can do grounding, there's various ways of getting electrons bypassing just eating food and getting it from that way.
I guess if I could just come in, because this is something that Ira and I have been puzzling over really ever since we bought the AquaCure machines, which absolutely do something. I mean, I've had mine, we've both had ours now for, I don't know, a month or so. And even in that relatively short space of time, we can notice differences. So there's no two ways about it. They definitely do something. But what we're puzzling over, I think what Ira's already said, and I'd just like to really ground it out, is these little things, which well, it's just electrolysis that goes on, okay, are obviously producing hydrogen. We've tested it. We've put in OLP meters, so we know there's an electron charge happening. And so with what you just said, George, some hydrogen and a negative electrical charge must stress that it has to be a negative electrical charge because normal water is a positive electrical charge. So it has to be that, which these little things do. But there's obviously something different in the Brown's gas machine. I know the coal plasma, as you've often said, is a high source of bioavailable electrons. But there's obviously something still which neither Ira or I have the equipment to measure. It's just the intrigue that we have is to try and measure stuff. It's like yourself. You want to measure things.
It's
You
not
can
just
see stuff.
quantitative, George, where, there's some qualitative thing. I mean, I've been on this only 3 weeks, and, my toes on my right foot were kind of numb, and now they pinked up and they're very, very mobile. I know you talked about it with yourself. I mean, that to me, I don't know how long it took for it to happen to you, but for me, that's like a miracle.
So, so really, both Ira and I are just as excited now about the AquaCure machines as we ever were, because we know they do stuff, and we've experimented on ourselves. But we're trying to understand if there's any way we can actually measure the difference of the output, if you like, from an AquaCure machine as opposed to something like this, which is a sort of a miniature electrolyzer. And I guess maybe, unless we've got thousands of dollars, maybe there is no piece of equipment that we can use to measure it, or a spectrometer or something like that.
So in other
Um,
words, how would the average guy know that Brown's gas is Brown's gas if he wanted to have a way of measuring it, or is there no way of measuring it easily?
That's a really good question, and I'm really still trying to find the answer. I can infer it with the various things that we're talking about, with efficiency measurements, for example. Like there's no way a regular electrolyzer will make 130% gas. There's 30% more gas than it should, Faraday-wise. There's no, I can show the spectrographic analysis, which you can infer the percentages in the gas by the peaks of the various elements. And we've got things like this EZ gel effect that happens with the Brown's gas, but not with the oxyhydrogen. And in that particular case, in those bottles, they just make hydrogen-rich water, not oxyhydrogen-rich, because they throw away the oxygen, because it's on the other side of the membrane. They just throw it away. By the way, you should always use distilled water in those things. They'll last longer and make a pure gas. You don't want to put in water that has chlorine in it, for example, or you end up possibly inhaling some chlorine gas. So and the membranes tend to plug up with micro things that end up being in the water anyway. So distilled water is the best thing to put in. It'll make your bottle last longer. And people should be getting at least the hydrogen-rich water. But another thing that I point out with those particular kind of bottles is that in 12 seconds of inhalation, I get as much hydrogen into my blood as drinking a liter of that hydrogen-rich water at 1.6 mmp. So parts per million, parts per million, ppm. Yeah. Okay. So and I'm inhaling for hours at a time. Obviously, I couldn't get as much hydrogen in me drinking as I could just by inhaling. So another advantage of the Brown's gas over those water bottles is that. But for making hydrogen-rich water, they're fine. I like the Brown's gas bubbled water rather than the hydrogen-rich water in those bottles, because you do get that extra of the electrically expanded water as a gas in the water as well. So it ends up being more therapeutic. There is a paper, hopefully soon, it's been in the process for about 3 years now, coming out of Germany, a university there I was collaborating with, where they took zebrafish. And zebrafish, you can see right through the fish, so they're used a lot for experimental purposes. And they bubbled Brown's gas in the zebrafish tank, in not the control, but the regular tank. And they discovered that when they would nip the fins of the zebrafish, they would heal 30% faster with the Brown's gas than just with the regular hydrogen mixture in the water. So just for healing of wounds and stuff. And as you're talking about neuropathies, I don't know when my neuropathies on my legs healed. I just noticed that because in the palm of my left hand, I had there was a burning sensation, and then it would go numb, and then a burning, kind of like a rainbow, and then go numb, and it had reached up this far, and I was thinking my fingers were going to go numb. I was going to lose the sensations in my hand. And I noticed that I was getting feeling back in my hand, and it's been 100% full feeling. That took about 6 to 8 months of inhalation for that to happen. And then I realized when I had feeling back in my hand that the neuropathies in the front from my knees to my feet on my shins had come back as well. And I had been to the doctor and they couldn't explain why I was losing the feeling in the fronts of my legs. As far as my hand was concerned, they said it was probably a damaged nerve in my elbow that was affecting my hand. So obviously, nerves in the skin have healed with the Brown's gas, and I have a whole bunch of other anecdotal things as well, and hundreds of testimonials from people of all different kinds of ailments. It's almost like just fill in the blank. Does it help fill in the blank? Because we're 62% hydrogen by volume in our body, not by weight. Hydrogen is a very light molecule or atom, whichever way you're looking at it. And our bodies are designed to hold as much hydrogen as possible, not lose it, because of course, as soon as it goes out in the air, it just, I call it goes to God. Just it's such a light molecule that it just floats up in the air. So we'd have very little ambient hydrogen around us, but it's something we really need. So we're getting it from our food. Anyway, you want to jump in, Jim, at all?
Well, the truth of the matter is you're talking about things I've never been exposed to. And so I don't really have too much to contribute in that regard. I did get one of your machines, and I'm almost ready to start producing the gas and using it. And I do have neuropathy problems in my feet. That started as a result of a car accident where I was rear-ended by some idiot that was doing 70 miles an hour and texting at the same time. So naturally, I would like to clear that up. Of course, I have a few other things. At my age, you always have something bugging you. But I'm very interested in pursuing the use of your equipment for that purpose. And naturally, once I start seeing some kind of improvements, I'll let you know. I'm not shy.
That sounds really good. And it's unfortunate that Yul Brown died of an infection. Like
Well, I know he has some really weird habits.
I'm laughing because he told me the story, but go ahead.
One of them really astonished me. I forget what the isotope was, but he was carrying assorted isotopes in his pants pocket. And I said to him, that's not going to do very much good for your
genetics.
Yeah, let's leave it at that. And he laughed and he said, I don't care. I don't use them anyway. So, but I mean, it could have had other effects, like cancer or whatever. I mean, I don't know exactly what he died of. I was just sorry to see him go because all things considered, the guy made a contribution they were all essentially intrigued with. And it's the way it happens sometimes,
Yeah, I was also fascinated, George, with I'm sure these were your comments. I've seen so many interviews with you, I can't keep track of them anymore. but I also visit your website often, which has a ton of information. So you are claiming is not the word that I want to use. It sounds too egocentric. But you're basically saying that the expanded water is the fourth phase of water, not easy gel. Am I correct?
Correct. Easy gel isn't water. It's H3O2 negative. You wouldn't say H2O2, which is hydrogen peroxide, is water. So H3O2 is still not water. H2O is water. And the electrically expanded water, or this plasma form of water, is still H2O negative. So it just got extra electrons on it. But as soon as it loses those electrons, it goes back from being a gaseous form to a liquid form. And that's
you're also saying, if I understand correctly, that the expanded water, electrically expanded water, is charging the easy water in the body. Am I correct?
It's making more easy gel in the body. Yes.
Is it more, or is it storing more electrons? I'm trying to understand that difference. Does it increase the amount, or does it increase the charge? Is it like
it does both. When you make the thicker layer of EZ gel, it has more electrons in it. There's more charge It's not more voltage. It's the
But
potential state.
it wouldn't concentrate it more though. In other words, if you had a fixed amount of easy gel and you exposed it to electrically expanded water, would it increase the charge or just make more easy gel?
It makes more easy gel, which increases the charge. It'd be like if you had a battery and you have now two batteries, you've increased the charge.
And did I also read that? I mean, this is in my field because we're talking about rouleau formation, which I want to ask you about also. But I also read, and I know from my own work, that red cells can lyse. Okay. In other words, when you get stacks of rouleau and there's not enough oxygen because you're compressing the cells together, the red blood cells become starved for oxygen. And one way of reaching out is that they lyse and then the hemoglobin leaks into the plasma. But I read somewhere, and again, I've read so much I can't remember. I should keep better notes. That the easy water, not the easy water, I'm sorry, the Brown's gas, okay, can actually increase the charge inside the red blood cell so that it will hold on to the oxygen, even though there's some kind of lysis going on.
Uh, I'm not an MD, so I'm just going to give you my opinion, which is conclusions that I've reached so far. It doesn't increase the overall charge in the red blood cells. It adds a charge if there isn't one. If there is a charge, it doesn't give it more.
Right.
It
But
doesn't
if it was lacking,
voltage or the potential. It's as soon as it's electron rich in the red blood cell, that's it. You can make the gel thicker on the outside of the cell, actually on the inside of the cell as well, because it turns out that this easy gel is what plumps up all our cells in our body. We're
right.
pretty much made of this easy gel. We couldn't exist without it. So but what happened with this most recent, or like, I guess it isn't recent anymore, 2 or 3 years ago with the pandemic, they were misunderstanding the virus was a blood virus, not a respiratory virus. So when the blood oxygen went down, the reason it was going down is because the virus was tossing the heme or ferritin or iron or whatever you want to call it out of the red blood cells, and therefore the red blood cells couldn't, with this little charge it can have with the iron, wasn't having the oxygen attached to it. So overall in the body, the oxygen levels would drop because the blood couldn't accept oxygen. Now, they put these people on ventilators to increase the oxygen pressure, but since the blood couldn't accept oxygen, it put some more oxygen in the plasma, but people were dying still because.
Yeah, it doesn't get into the cell.
Now, the point coming back
Yeah.
is that as soon as they started inhaling Brown's gas, and there's been quite a few studies now done in China, that's what they were using in China as the number one treatment for this particular virus. As soon as you started inhaling the Brown's gas, the oxygen levels of the blood within 5 minutes started to come up to normal. And within 3 days, the people were walking out of the hospital, never having seen a ventilator, didn't have to have a ventilator, just inhaling like I am right now with the Brown's gas. So it was.
Can I just make a comment, George? Because I know after the last chat we had, I got all sorts of emails about viruses because that's one of the things. I won't go into it too much, but what you're saying is quite correct. But the reason people were becoming ill was not because of a virus, it's because of the electrical charge changes. And as you've already said, the Brown's gas restores those electrical charges, and that's why people were getting well. We found, and it was a doctor, I think it was a Midwestern doctor, if I remember right, Ira,
Yeah.
had said that he'd seen that, particularly with the vaccinations for COVID, that they were destroying the electrical charge, causing rouleau, causing blood clots, and that was what was taking people out. So it's nothing to do with the virus. It was all to do again, as we keep finding, all to do with the electrical charge and not having the correct electrical charge, which Brown's gas obviously restores, and that's why those people recovered.
Yeah, the
after
Japanese were
having
actually
it.
the first ones. I went to the Japanese because they're always ahead of everybody else when it comes to this research. And the very first thing that they noticed were these microclots. And I was very familiar with it because I studied rouleau formation for like 30 years. And that's exactly what happens. So if the electrical charge in the blood, and the key, by the way, and we talked about this in the other podcast we did, The thing that makes the rouleau formation actually happen is a reduction of the negative charge on the surface of the cell. But what's responsible for that is what happens in the plasma. So what would happen with the quote unquote virus, whatever you want to call it, okay, is that the zeta potential, electrical potential on the red blood cell is normally like minus 20 millivolts. If it gets attenuated and starts driving towards an isoelectric point, okay, that weakens the repulsive force, and that's how they stack up. But there's clearly an intelligence there. It's not a mechanical process because you can see that what's making them sit right on top of each other, which is very different from coagulation. But the end result is still the same, is that you're starving for oxygen because you have less surface area available for gas exchange when it goes into the lungs. And the pH is also important, which I mentioned in the other thing, that the more alkaline the pH is, as the blood comes into the lungs, it'll pick up more oxygen if the pH is alkaline, but when it comes to dumping it into the cells, it'll hold on to it. Whereas if you have an acidic pH, it will pick up less, but it'll let go of it more in the cell. In either case, it's not good because ideally in the arterial blood, you want a pH of 7.4. But then when the cells begin to break down, okay, it's just when you cut yourself, if you cut a capillary, the body's going to send platelets there, to patch that up. But very few people know, and I used to observe this under the microscope all the time and just found a great article on it. I didn't know somebody did research on this, was that the red blood cells themselves, what you were talking about before, where they expel hemoglobin into the plasma. When they bleed, red blood cells bleed, not just the capillaries, then the body produces even more platelets, and the platelets go in to fix that. Then it becomes this very thick, gooey mess that you can't break up at all. And that's where you can die and have these gigantic thrombi, what they call it, or embolisms that can cause that. So to me, one of the great things about the Brown's gas is that will bring enough electrons there to increase the zeta potential back to normal. And that breaks up the rouleau, allows the body to oxygenate, and will allow things to heal quicker. And that's not just in COVID, that's in any disease. When I did my research back in 1982, I realized that if you could break up rouleau formation, you're giving a real boost to the immune system because now you have all this oxygen available, to heal. And the degree to which, you had more or less rouleau formation will determine, the level of health that you have. So it's a fascinating thing, which now leads me to my next question, which we didn't get answered last time. When you talk about high energy rouleau, what do you mean by that? It sounds like it's a positive thing, but to me, it's actually a negative thing because to me, any kind of rouleau is going to be harmful. So can you explain that?
Okay. Again, I'm not an MD, so I'm just going to explain what I saw and what the results were, which is similar to what I explained before. So I'm sorry about the redundancy, but it wasn't until I had dark field microscopy of my blood done that I even knew there was rouleau involved. And it turned out when I was doing it that when I'd start to inhale, within about 15 minutes, I'd have rouleau formation in my blood. Okay. Now I knew I was putting extra energy in my blood, so this is why I'm calling it high energy rouleau, because when you're talking zeta potential and stuff, when there's a difference between the plasma and the charge on the red blood cells, and somehow in there, if there's too much of a difference, you start getting rouleau. And if you have low energy, what I call low energy rouleau, that means that you're losing your zeta potential, and the charge is going that direction, and you're getting the rouleau formation, which is like the red blood cells stacking together like magnets, which to me says there's a difference in the potential of one side of the, which shouldn't exist, but for some reason does, between one side of the red blood cell and the other side. And maybe it's because of the iron in it, because the iron can make a magnetic electrical charge, or charge them in, so you have a north and south poles, and so they can stack together that way. So maybe it is more like magnets than I was thinking about before. But the point is, when there's this difference, you get the rouleau. And I see that there can be a difference in low energy and high energy. So I'm adding energy and getting a rouleau, And as the energy dissipates in the body, like when I stop inhaling, then within about 15 minutes, my blood is back to normal. So then, having done that with myself, we got interested, and we got several other people that happened to be in the lobby where this stuff was being done at a Tesla convention, and exactly the same thing happened with them. When they'd start to inhale, within about 15 minutes, they'd have the Rolu formation, and in about 15 minutes after stopping the Rolu formation, the energy had dissipated in the body, and the blood went back to normal. So
one of the things
lots of finger pricking was going on.
yeah, I'll bet. I mean,
So
what,
the other important thing was we measured respiratory rate and heartbeat rate and blood oxygen with oximeters, finger held oximeters.
Yeah.
And we found that if anything, the oxygen level increased, the blood rate, the pulses per minute went down. So but I hadn't measured blood pressure. I had gotten back to you with emails as far as that concerned. And recently, I went into the doctor and they said I had high blood pressure. So I got a cuff and started measuring my blood pressure and comparing it with not inhaling Brown's gas at all as to inhaling long hours a day. And again, we found with the blood pressure that the Brown's gas made very little difference, any immediate difference in the blood pressure. If anything, it's slightly lower, like about 10 milliliters of water less with the Brown's gas, which, by the way, also brings me back to the EZ gel and solving 3 medical mysteries. Have I told you guys about that?
maybe you have to.
Okay, so quickly, inhaling the Brown's gas is more healthful because it increases the EZ gel in the body. Virtually everything in the body is hydrophilic. So you get this gel happening on. And there's 3 medical mysteries. First of all, why is a red blood cell, which is twice the size of a capillary, able to go through a capillary instead of stopping it like a cork? Why is it that they can prove that the heart pressure, the pressure beating on the heart, is not enough pressure to push blood through all the hundreds of thousands of miles of capillaries in our body? And the third thing is, why is it that the top of my pointy head, see the point there? Is it pointy head? To the tips of my fingers, to the tips of my toes, why is an even blood flow all through my body? Because hydrodynamically speaking, fluid always takes a path of least resistance. So you would think it would just simply go around the thoracic region and back and not go to the ends. Well, they discovered, Dr. Pollack discovered, Professor Pollack, I should say, discovered that if you have a tube small enough that has EZ gel in it, it will spontaneously start to flow fluid with no pump or other energy input. And that's the size our capillaries are. So all our heart has to do is get our blood to the capillaries, and the capillaries actually do the pumping. Actually, the heart makes a positive pressure, so it makes the blood flow one way, and it goes to the arteries on the other side and back to the heart. So the capillaries, first of all, you have the EZ gel on the outside of the red blood cell and the inside of all the capillaries, and it's negatively charged, so like charges repel, and gel is slippery anyway, so that's why the red blood cells can go through with minimal resistance through the capillaries, and then you get the capillaries themselves doing the actual pumping. So that solves the 3 medical mysteries of why the EZ gel is important. So inhaling the Brown's gas, which we've proven increases the EZ gel significantly, should eventually, over a period of time, help. And it may be one of the reasons why, even though they call it the silent killer, high blood pressure, I'm not exhibiting any symptoms of having had high blood pressure. Now I've got my blood pressure down to my normal, which is about 140/90, consistently with virtually no medication. I'm taking things like beet juice and stuff like that, and getting exercise. It turns out exercise is really important, and it was the one significant thing that would drop my blood pressure a lot, down to, I've even had it as low as 116/60, and that is too low as far as anything is going. Although the normal that they used to have was 140/90, and then they reduced it to, I think, 120/80, and now they've recently reduced it again. And I think they're doing it simply to sell more drugs.
Yeah, no question. Yeah, no
Definitely.
So I think my blood pressure is a normal. It is my normal. I've been 140/90 for most of my life. It's just when it got up to 160, the doctors started to freak out, and it turns out that the sitting in my chair for 8 hours a day was killing me because I needed to get up and go do some exercise, as far as that is concerned.
Yeah,
However, I think Brown's gas really helped.
yeah, the fascinating thing though, with the not parallel so much, but the relationship between your work and Pollock's work is amazing to me. For instance, I know you guys call them capillaries. I call them capillaries. But for
Capillaries.
instance,
Yep.
the capillaries in the lungs are actually smaller than the diameter of a red blood cell. But red blood cells are like mice. They can collapse and then they can just move their way through. If they even if there's rouleau formation, you'll see three of them attached to each other, but they will still manage to squeeze their way through. But a lot of people also don't know that in all our blood vessels, not the veins, but the arteries, that there's smooth muscle in there, which helps squeeze it along. You know, but the thing that makes the smooth muscle contract, okay, and easy water, when I read Dr. Pollock's books, pulsates. So when it pulsates, it also stimulates the smooth muscle to help push that along. I know that because when I took arterial blood from all my patients, it hurt. And they said, why are there nerves in the blood vessels? And I said, well, they're there to stimulate the smooth muscle to help push it along. So we know that the heart itself is not strong enough to do that. But it's clearly also an electrical phenomena as well. So the relationship between the two works are amazing to me. But I still have this question, and I'm not trying to give you a hard time. This is thinking openly. I I discovered or came to the conclusion that the rouleau formation was a defense mechanism of the body. Okay, so what happens is as the zeta potential reduces on the red blood cell, the body, the liver, and the spleen both sense that there's a low charge, and that's how cells get eliminated from the body. They age, every 90 days, and the reason they're eliminated is because the liver senses there's a low charge, takes them out of circulation. But you can have an acute situation where your energy level drops. So as soon as that happens, you could have a common cold, wake up in the morning and feel lousy. The cells clump together, but that clump increases the charge. In other words, it's like safety in numbers, and it doesn't get eliminated. So what I'm saying is that in every single case that I know of, even though rouleau formation is doing a positive thing, to defend itself, it still has negative effects if it becomes a chronic condition over time. So what I don't understand is if we're supplying the body with all these electrons, with Brown's gas, and I do think there's something unique to it, and I have theories about that too, but if we're supplying it with electrons, which would keep the zeta potential normal, and that seems to be a great benefit, why, when you would inhale Brown's gas, would it form rouleau formation? It doesn't make sense to me.
I can only say what I've observed, and sometimes the science just has to catch up to the practicalities of what we observe, and what we have to be really careful with as an inventor. I discovered there was a quote from a California university: "If we can't measure it, it doesn't exist." Which reminds me of a quote that the patent around the turn of the 1900s, the head of the patent office said, "We might as well shut down the patent office because everything that can be invented has been invented." And I'm seeing that we have a lot to learn yet, and that's kind of where we are as far as this is concerned. I've seen massive better health in the population, everyone who's inhaling Brown's gas. So I'm a believer that it's more beneficial than not. And I don't know the exact mechanism of why the rouleau formation forms, but I'm calling it the high energy rouleau formation as opposed to regular low energy, because I think those extra electrons do make the difference that causes the potential between the red blood cells and the plasma to be different. So But we can also see that as the charge dissipates, so does the ReLU. So it maybe that's one way that the red blood cells are just accumulating more of this charge so they can get it out to the body where it needs to be.
You would think that positive, that it would be a positive charge, not a negative charge, because the normal charge, like I said, is negative 20 millivolts. For instance, if somebody gets sick, is really sick, what happens is that the liver releases fibrinogen, into the plasma. And the fibrinogen is a positively charged macromolecule. So that reduces the negative charge on the red blood cells, and that's how most of it is explained. But there's like 20 or 30% of the time where there are no macromolecules in the plasma, and nobody has an answer for that. And I think the answer to that lies in Reich's work about his discovery of orgone. I don't know how familiar you are with this. I brought it up once before, but we never talked about it. A little bit. Okay. It's kind of like the 0 point energy, so far as I'm concerned. But Reich's basic theory is, it wasn't a theory, that he proved that there was a basic energy in the universe, which he called orgone. It was mass free. Okay. And everything is secondary to that. So when I think, and David, now that he's been exposed to it, we think backwards now. It's like, what is that funded? Everything is an expression of that. So I think the Brown's gas, and this is a possibility, that's why I asked this question before, that when you're doing the electrolysis without the membrane in there, that in some way that you are deconstructing the water and returning it to its mass-free state. And if that's the case, that could explain the health benefits. Because Reich, for instance, was able to build a box. A lot of people heard about this, the orgone box that you could sit in and concentrate the energy and charge people up. And that was mass-free energy. And that's the purest form. And I have a sneaky suspicion that that's what's happening with the Brown's gas. And I would love to see more work done, with that. One simple way of doing it would be, what you can do with easy water, I would think, is just take a glass of water that contains easy water. You can buy, a friend of mine makes these things, small orgone accumulators, many layers, and just stick the water in there and then see if anything changes with the easy water, or if it would have an effect on the Brown's gas. I would love to do research with that. So I don't know, Jim knows about Wilhelm Reich's work too. So based on his knowledge of Brown's gas and that, I'd like him to comment on this.
Well, as you were talking, one of the things that was running through my mind, which is a relatively new thought for me, so I kind of paid attention to it, is, there might be another way of looking at all this stuff, which is so obtuse that most people probably wouldn't consider it. But if you have the two extremes in a pH measurement, that you go from acid all the way to alkaline, or the other way, depending on what you're doing, that might be a biological expression of the same set of laws at a different octave of expression that you see in the electrical world, where you're moving from inductive phenomenon to capacitive phenomenon. And the interesting thing about that is both of them incorporate a phase shift. It's much easier to talk about a phase shift in terms of the electrical world, because there's so much stuff that allows you to measure it. But I'm still very confused about what phase shift means chemically or biologically, because I just don't have the experience there. But that doesn't mean it doesn't exist. And, we might be talking across purposes when we try to look at these things as being separate. I'll give you an example of what I mean by that. Years ago, when I was working for Bethlehem Steel, they had a problem with their demand, and the electrical plant was so huge that they were being crucified by the power companies price-wise. And of course, power company was very pleased with this arrangement, but Bethlehem Steel was not. So I said to them, well, you know, you got an electric shovel that you're getting ready to junk. I said, why don't you give me the guts of that thing, and I'll build you a synchronous capacitor, and we'll have the opportunity to screw the power company for a change. And so exactly what I did. Now, the thing that's interesting about a synchronous capacitor with respect to a fixed plate type capacitor is the fact that once you get into that sort of thing, you rapidly discover the fact that you are really dealing only with a relative measurement of the position of current with respect to what you're using as a voltage standard. And as a result of that, without changing anything except you're moving the current with respect to the voltage or the voltage with respect to the current, it changes the entire dynamic of what you're playing around with. So if you actually chart this graphically, what you actually see is that you start off with a very lowly excited or unexcited three-phase motor, for instance. You're way the heck up in the inductive range. And as the excitation grows, now this thing comes down and goes through a plateau of resistance, which is where most motors like to run. And if you keep on increasing the excitation, now it dips the other way and becomes capacitive in nature. And so you have this whole big spectrum of changes, which are only based on a relationship of two quantities, one with respect to the other. I don't see why you couldn't have something similar going on in the blood system or in the nervous system or wherever you want to investigate it, because the universe has a tendency to do things in terms of octaves of expression, where it's basically using the same thing over and over again, but it's applied in a manner that is particular to the environment that it's being manifested in. And so I don't see why that couldn't be a case here. Like, for instance, George is talking about a high energy relay with respect to your interpretation of a low energy relay. That sounds like a phase shift to me, where you're going from one extreme all the way to another extreme, and you're passing through all the intermediate stages in the process of doing that. And so the real trick is to understand what you're measuring with respect to what. Because if you try to do the same thing electrically, and let's say you couldn't measure the voltage involved, how would you know what the heck you were doing? Or you couldn't measure the current involved, or you couldn't measure the power factor involved. I mean, all of these things are so fundamental that when you're being taught this stuff in engineering, you just accept it. But if you don't actually get out there and play with it, I got news for you. You won't know what the hell it means. You'll only know what the definition says in the textbook. You won't have a gut feeling for what it is that you're doing. And I've always tried to take my work to such an extent where I understand it so well that it becomes second nature. And you look at other things and it's, oh, that's the same damn thing all over again, but in a different form. And I think that that's kind of what we're talking about here, even though I don't have any experience in that direction directly. It feels that way to me. And George would probably be a better person to bounce these ideas off of from a biological point of view than I am.
But I think what you're saying is important. The one thing that we do know is that the body always acts in the service of trying to help itself. that we know. And all I'm saying, I could be wrong, but I don't think so, is that the rouleau formation is a defense mechanism to help the body. If it becomes a chronic condition, then of course, it can harm the body. So what I don't understand still, and obviously we're going to have to do some research on this, is if it's true. I forgot to ask you, George, did you do it before a finger prick to see that your cells were separate, or did
Yes.
you did?
Before,
Okay.
about every 5 minutes for about a half an hour, or actually more than, I think the whole thing was about 3 hours long during that particular thing. But
Right.
we were doing before inhalation at all and seeing the blood normally dispersed, the red blood cells normally dispersed, and then start to inhale, and you could see some rouleaux start to form as we pricked again every 5 minutes until 15 minutes. It wasn't a lot of rouleaux. Like we're not talking the whole thing was clumpy everywhere. I'm just saying there
Right.
was some rouleau formation, and I have pictures of it. They took pictures of it, and I have a document. I don't know if I sent it to you or not. The Walter Russell document, maybe remind me. I'll send you the document. It'll
Oh,
show some
okay.
pictures. So and then stopping inhaling, and keep pricking the finger and watching each sample until it was back to just dispersed red blood cells again.
So did you ever do a rouleau formation thing? After hours and hours of reading this to see if it was still there. And so what
I
I'm thinking
I
is
have
that
not. No, that was only just those short periods of time. I really would like to, and I don't think these blood dark field microscopes are very expensive these days. So I
no.
think it would be nice to get one and then just have some fun with it.
Yeah, I'm betwixt and between with microscopes because I'm trying to get this phenomenal microscope. I have a patron, so I haven't bought any other ones, but I will do that test. But what I'm thinking is the possibility is the fact that when Brown's gas is introduced, because it's foreign to the body, it's because I think it has some special qualities. Maybe the initial reaction is some rouleau formation, but maybe if you tested it hours afterwards, that would just dissipate and then things would go down again. It's something that we would need to do. But I'm glad we're talking about this because it was, addling my mind. It didn't make any sense to me, but clearly we have a lot of research to do yet.
So let me ask
we're
you something, Ira. Let's say we're talking about normal rouleau, which is indicative of a problem with health, or at least with the blood. What is it exactly that is off voltage-wise? In other words, whatever you're measuring, and I don't know anything about it, so you're going to have to explain it to me, but whatever you're measuring is if you measure a voltage, it's actually a gradient that you're measuring. It's not just this floating around value. It's with respect to something. Okay, and so what is it that you're measuring with respect to what that gives you this number, which obviously varies as something changes in the blood? Well, let's call it the pH, because that's what it sounds like it is. So anyway, what is the answer to that question? That would help me think about this, because
Yeah.
you're the one with the I don't have one.
Well, I'm not the one that discovered these things, but certainly it's the milieu that the red blood cells are in. So it's measuring it in relation to the charge also in the plasma. Now, my understanding that the charge in the plasma, when it's measured, is only -7 or -8 millivolts, but the charge on the red blood cells, okay, is -20 millivolts. Now, why the body created things that way, I don't know, but I know that those are the basic charges. So now, for instance, if you get sick and you're releasing these positively charged macromolecules into the plasma, okay, that's when the charge on the red blood cell gets attenuated. It moves towards an isoelectric point, and the rouleau formation begins to happen. That is my understanding of what goes on there. Now,
What
it,
would you imagine would happen, for instance, if you had the same potential difference, but it was caused by an inversion of that process. In other words, you're talking about measuring the plasma voltage with respect to the voltage or the potential, I should say, on the red blood cell, and one is higher than the other. Supposing the red blood cell had a higher potential than the plasma, I can see where that would still clump, but now you'd have a different explanation.
Well, when you have the negative 20 millivolt charge on the red blood cell, there is no clumping. That's the point. In other words, all the cells are separate, and the charge in the plasma is -7. I don't know if we ever talked about this, Jim, but I know I told George about this. This guy named Robin Farias, who developed this test called the erythrocyte sedimentation rate, he's the one that really studied rouleau formation more than anybody. And one of the things he did, which I repeated, is that he had a really sick person, and he took those pathological red blood cells from a very sick person that were all clumped together and put them in the plasma of somebody who was healthy, and there was no rouleau formation. And then he reversed it. He took healthy cells and put it in pathological plasma, and there was tremendous rouleau formation. So we know that the factor that's affecting the red blood cells has to do with the plasma more than the red blood cell itself, if that helps your reasoning at all.
Well, potential is a very peculiar situation because you can have the same voltage, if you want to use that term, but it can be the result of a distribution of charge. Like you were saying, you got two negative values really, but one happens to be bigger than the other.
Yeah.
Okay, so you can still have two negative values and you can reverse the situation where one's smaller than the other. And that's actually a different condition. It could actually give you the same voltage, but it represents a whole different situation.
Yeah, I don't know if you're familiar with this, Jim, but in Pollock's work, he has like a little chapter. I know, George, you're familiar with this, where he talks about likes. You remember that? Okay. That theoretically, if you have two negative, things, he did it with microspheres, they would repel each other. Okay. But then if you have a positive and a negative, they should come together. But what he is saying, that you can have two negative charges that actually like each other. So if in the plasma, okay, something is happening, it doesn't necessarily have to be a positive charge. It could be some kind of attenuation of the negative charge that's already there that can cause the rouleau formation to take place. I don't have the answer to that. I don't think anybody does at this stage of the game, because he was using microspheres, and I don't know if he's done any, George, experiments with blood or not, but he's the next guy that we want to talk to, and maybe we can do it amongst all ourselves here. I think it would be fascinating. But you raised your hand, George.
I don't know, Ira. You remember we looked at that microspheres experiment.
Yeah.
Because we both had, well, I certainly did as an electrical person, this likes just didn't make any sense to me at all. And when we looked at the experiment, that was almost an optical illusion, because you've got the negative spheres, which seem to be being drawn together, likes. But when you look at what was happening between them, there were positive charges. Right. And they were being attracted to the positive charges, really, which made them look like they were being attracted to one another, but they weren't. And that's really important.
A mislabeling there. Yeah.
Yeah.
George, I saw you had your hand up before. I didn't mean to.
Yeah, there were several different comments on the thing. As far as Oregon energy goes, back in my days of fuel saving days, if you wrapped the fuel tank of a vehicle with alternating layers of like tinfoil and newspaper and stuff to make it an Oregon accumulator, it would significantly increase the fuel mileage of the vehicle.
And interesting.
It comes back to these same sort of things are applicable over different technologies. And
so can I ask you, when you did that with your alternating layers, when Reich built his Orgone box, okay, the inner layer had to be metal and the outer layer had to be organic, because the metal attracts Orgone and then repels it, and then the organic material attracts it and holds it. So if you keep building up layers, the very inner layer, which has the metal in it, will concentrate the energy, and then it superimposes with the energy field of the person and increases their charge. And you're telling me that you did something like that and it got better mileage?
Yes.
That's incredible.
It is, isn't
Yeah.
it? Yeah.
So
He's the orgone expert, not us.
just experimenting, doing things. So the
Unbelievable.
phase shifting, comment on the phase shift, that's really good thinking. I kind of just keep an idea on that. And it's absolutely true that if you get the power factor out of alignment, you're a lot less efficient on your electricity. So that was great with the Bethlehem steel, saving them a bunch of energy there. I also noticed that when you're talking about things being done the same, it reminded me of the Fibonacci and fractals. Fibonacci principles and fractals, where fractals you get the larger and it comes down, 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 down. Fibonacci is all through nature. You got different kinds of spirals and things that happen. So, and then coming to the magnetic charge, I'm thinking based on what we're talking about here, if the red blood cells have a potential of about 20 and the plasma about 8 or 9, and that makes it normal. And then as the red blood cells lose their charge, so go less negative, then you start getting the ReLU happening.
Right.
Well, maybe what's happening is the electrons in the Brown's gas aren't going on to the red blood cells so much as going into the plasma. And if you increase the potential of the plasma from 8 or 9 up more toward 20, well, then maybe that equalization is causing the just a thought that's in my head. And if you have access to somebody who can measure these differences, that's going to be really nice to see.
I think I know some people who can do this.
Well, you know what's interesting, George, about what you just said, which is kind of a variation of what I was thinking or where I was going. If we look at the first condition for the type of rouleau that is detrimental, let's assume that that's an electrostatic process, simply because of what Ira is explaining about the difference in charge between the plasma and what's actually on the charge that's on the red corpuscle. Then you brought up an interesting point where under certain conditions, you have the actual iron component in the red blood cell playing a different role. And it could be that if you reach that set of conditions, and I don't know what they are, now you've moved from an electrostatic condition to a magnetic condition, which would still cause the same attraction if the poles were correct. And there sure as hell isn't any problem in flipping a red blood corpuscle because they spin and rotate all the time. Now you could have a different type of rouleau. So you're getting back to that same situation of power factor in blood, if you want to look at it that way, where you've got a capacitive condition on one side and an inductive condition on the other side. And the area in the middle is straight resistance, which is the norm, so to speak. So, there's a very interesting set of things there. Now, one of the things that might make sense, and I don't know how to do this, this is more in the province of Ira and possibly yourself, but if you start inhaling this Brown's gas and you could actually look at what the blood is doing as you are doing it, as opposed to after it's happening, wouldn't it be interesting if you started to see red corpuscles making a rotation before the rouleau starts? Then that says something very fundamental about what forces are actually acting, because I don't see any reason why the human body, as complex as it is, can't have electrostatic and magnetic features to it. All psychics will tell you that the aura of the human body is essentially electromagnetic, which encompasses both of those features.
I'm so glad you brought that up, Jim, because I have a book, the best book I've ever seen on red blood cell aggregation, and that is exactly what happens. These guys have seen this, and they've seen it actually rotate and line up. There's an intelligence there, so I think you got that. That makes
That's just
eminent sense.
sitting here listening, which is one of my better attributes.
Well, that's
Right?
why we asked you to be here. Wasn't for your good looks, we know that. We've known each other 40 years. We can do this. It's okay.
Well, I'm actually liking his mustache. I think you got a good job.
You have a meaning to talk to you about that, George.
Parker, I'm really relying on your gas to help me with that.
So what do you think of that, George? What Jim just said?
I think it's absolutely correct. And actually, it's one of the things. Did you read Professor Pollack's new book, Charged, yet by chance?
No, I didn't know it was out.
It isn't. Some people, and I guess I was one of the fortunate few, got an advance copy. And when you read that, you're going to see essentially that same sort of thing, where there's different. When you think about it, it comes down to our science. The way we're thinking of it now is not all inclusive, tends to categorize things. So you say magnetism, electrostatics, where there isn't any categorization in nature. It all works together. So it's really important to understand the electrostatics at the same time as electromagnetism. And I think that's exactly what we're talking about here. Electrostatics tends to cover the surface of something really evenly. So you wouldn't have a negative and positive pole or potential like that. So there's obviously, in my opinion, a bunch of the electromagnetism happening with the red blood cells, which being iron in there. And this doesn't happen a lot with anything else in the blood. Am I right with that? It's just mostly the red blood cells that does this ROLU formation.
Yep.
So I think the iron has a big component of that. So electromagnetism, whereas the EZ gel tends to be electrostatic in nature. But you can still have different charges, and the different charge potentials are going to cause that electromagnetic effects. I think it's all inclusive.
Yeah, one of the times that actually changes in the blood, George, is in the case of leukemia. Most people, Reich did a whole thing. He wrote a book called The Cancer Biopathy, and stated that leukemia is not a disease of the white blood cells. It's actually a disease of the red blood cells. And what happens is the red blood cells get so weak and lose their charge that's what causes the body's defense mechanisms to kick into place and produce all the leukocytes. But when the red blood cells actually weaken, they break open, and one of the common things that you find in leukemia is increased iron levels. And people don't get why that happens. And the reason it happens is because the hemoglobin is breaking out of the cell, looking for oxygen, to survive, so to speak. And then that changes the whole dynamic in the plasma and can cause even further rouleau formation. So, but I think what you guys came up with, it makes eminent sense. The intelligence that you see when you see the cells, like if you press on the slide, when you have rouleau formation and you see the cells break up, when you watch them reorganize, that's exactly what happens is they flip over. So you have a positive and a negative, positive, negative. You wouldn't have negative, negative because then they would never come together. So this is wonderful. This is all making sense to me.
Just a little bit of a comment that hinges on what George was saying about the universality as opposed to pigeonholing all these effects. Feynman, who was a very famous physicist, comes out with some really neat things, and he had a very developed gift of explaining things in such a way that you don't have to have a PhD to follow him all the time, although he could certainly address that crowd at their level if he wanted to. And one of the things he was talking about was the difference between electrostatics and electromagnetics. And he uses a beautiful analogy to get the point across. And basically what he asks you to picture is a merry-go-round in an amusement park. And he's got all these kids standing on this merry-go-round, and they're all holding a wooden stick with a little globe on the top of it that's made out of spun metal. And you impose a charge on those little spheres. And now you start the merry-go-round up, and there's a guy that's on the merry-go-round observing with an instrument what he sees when he looks at each of these kids. And so what he sees is basically an electrostatic field emanating from these little charged spheres. Now, the merry-go-round continues running at the same speed, and the only difference is that the guy steps off the merry-go-round, turns around, and uses the same instrument to view the same children. And now he sees a magnetic field around each of these spheres, or in its totality, as opposed to just an electrostatic field. And that's because we're changing our
Perspective.
changing the word is escaping me.
Yeah, I would have said perspective. Yeah.
We're changing our reference frame relative to what we're measuring. And all of this stuff somehow fits together. And I'm positive that there's going to be something relative in this type of exploration as well. What it is, I couldn't say at this point, but that's just the nature of things, you know. And the interesting thing about it is these ideas are very ancient. You know, a lot of people go gaga over Einstein, and don't get me started on that situation, because of his explorations into relativistic physics. But there's relativistic physics and there are relative physics, and they are not the same. There was a gentleman that actually was also a Serb who predated Tesla by about 100 years. And his name was Boskovic. And Boskovic in his lifetime wrote 1,000 volumes. Can you imagine 1,000 books on all kinds of different things, including the interchangeability of matter and energy and relativity? And guess who was familiar with Boskovic's work and came up with his version of relativity? I won't mention any names, but
Who that could be.
but the point is that even the Egyptians and the Sumerians were acquainted with relative measurements, and some of their mathematics express that. And if you get into it, you even wind up exploring various physical attributes of the Great Pyramid, for instance, and all kinds of other things. And the duplication of concepts down through the centuries is mind-boggling, but people are so used to focusing only on what's in front of them. It's like a horse with blinders on. They don't see these relationships. Like, for instance, I can easily show you relationships between the design of the Great Pyramid and the Orgone accumulator. There's all kinds of stuff like that out there. And I think that it's a tragedy that we're just too focused. We don't look at things holistically. And it's like Ira and I have had this conversation more than once. If you want to understand a cat, for instance, what's going to teach you more about the cat? Freezing it and cutting it into slices, or examining the animal in its holistic form? You know, there's some value in understanding the individual systems, but if you don't get the whole picture, you're never going to see it. That's just the way it is. And that philosophy is attributable to everything in life. I don't care what it is.
Yeah, I'm familiar with the elephant analogy where one guy grabs the tail and says it's a rope, and another guy does the trunk and says it's a snake, and another guy grabs the leg and says it's a tree trunk or whatever. Yeah, but it's all the animal and it's all there. I'm going to need to go, guys.
Ah, too bad. We were just
Can I
getting
ask,
warmed up.
George, can
Yes.
I ask one very simple practical question? And this is just to do with the use of the aquacure, because it just puzzled me. When we have to top it up, when the refill light comes on, I know that you've always said with the syringe is take the water from the dehumidifier flask and slowly pump it into the tower. Okay. And then refill your dehumidifier flask with distilled water. Okay. I'm just curious, if you do that over a period of months, as you've used it, isn't that diluting the electrolyte as you put in? Doesn't that
So it's the
dilute it over a period?
It's the opposite. First of all, it's an oxygen humidifier, not a dehumidifier. It
Oh,
puts
okay.
humidity into the gas. Theoretically, when you're inhaling oxygen, is very dry, so they put it through this particular one. Now I'm using the humidifier as a scrubber. So
Yes.
when the Brown's gas is coming out of the AquaCure, it is very pure. The gas itself is very pure, but it can contain water molecules as water vapor, that kind of thing. And the water vapor is actually little bits of water, and it can have a little bit of the catalyst or lye solution in it. And so
Yes.
when those little tiny micro droplets go through the humidifier, the water grabs them and it scrubs it out. So the gas you're inhaling is pure. I also go through the drinking water jar just as an extra. So I love twofers. I love doing two things at the same time. So at the same time as you're scrubbing your water with the humidifier, you're also accumulating that microscopic amount of lye. And then when you take the water out and squirt it back into the machine, you put that lye back into the machine. And then you're making your drinking water at the same time as having with the drinking water jar at the same time as having that additional scrubbing apparatus as well. You can have like 20 parts per million lye in water, and it's actually more healthy than just pure water, if you actually look at it. So it takes care of all of those particular things. And the other thing is when you refill the humidifier, completely dump out the remainder. Like after you refill the AquaCure, you're going to have about a third of the humidifier left. Dump that down the sink and then completely refill with distilled water. Don't just top it up. Let
Okay.
top it up. And because if you top it up, eventually what happens is the lye in there gets more and more concentrated. And over time, it'll stop being as effective a scrubber because it'll already have the lye in it. It won't be able to grab the lye as it's going through, as the gas is going through.
Okay.
So
I suppose the fact that, as you've said, George, I thank you for that because I didn't realize that, but now I know. I suppose that would explain when, just out of curiosity, tested the two bottles. You'd got a pH of 8 in the first scrubber, and only 6 in the drinking one. So that would, because obviously that one is much more acidic because of those little bits of lye that come through in that first one. I would imagine that's what
So
is that.
actually, lime
Okay,
makes
well,
it alkaline, and so
sorry,
and
yeah,
also the electrically expanded water increases the pH, makes it more
yeah,
alkaline. And
yeah,
there's been studies shown that the ionizers that they were using and saying for 45 years the alkaline water is more healthful for you and stuff. Turns out it had nothing to do with the pH. It had everything to do with the hydrogen in the water. So the Brown's gas bubbled distilled water, because distilled water is generally lower, more acidic in pH, like we're talking 5 or 6 or something like that. If you bubble with the Brown's gas, it'll come up more toward the 7, but it generally doesn't go above. Sometimes it does, more toward the 8. But the pH is all having to do with the electrons, which the ORP pH meter is measuring as millivolts,
yeah,
the potential difference.
yeah.
So that I'm just saying it's the pH, or the pH isn't necessarily lye. It could also be being rise because of the electrons in the electrically expanded water. So you always are going to have a higher pH in the scrubber, in the first humidifier, because that's what's trapping those little microscopic bits of lye.
Yeah.
Gradually, over time, the pH would rise in the drinking water jar as well. Hopefully I answered your question.
Yeah, it does. Thank you. Yeah. Okay.
Okay, I guess we should let you go.
Yeah.
It's been fun, Jim. I'm really looking forward to further communication with you. I think our two experiences can combine to make something better.
Well, you can feel free to contact me by phone or any other way you want to. These gentlemen can arm you with my information, and I'll be happy to receive you anytime.
Thank you, Jim.
Also, you only live in where? In New York State?
I was living in Canada. I'm a dual citizen, just above the. Okay, there was an alarm went off and it's gone now. Okay, it was probably my distiller now that I think about it. I was living in Buffalo and Fort Erie, and I'm just currently moving to Maine. So I'm actually, I think, a little closer to you in New Jersey at this particular point. What you're seeing out the window right there is the snow on the trees in near Bangor.
Oh, okay. Well, whenever you get settled, I'm not beyond coming to visit you either, or
Like,
vice versa.
yeah, that could be fun. Sounds good.
There's a lot of things we can talk about in private that we can't talk about on the air, if you know what I mean.
I know exactly what you mean. And if you knew some of the things that were going on in my life, you'd really know that I know what you mean.
Okay.
Oh,
Okay, well, thank you, George. If we're going to wind it up now, thank you, George, for your very valued input, and obviously thank you too, Jim. And I guess we'll let you both go off and carry on with the rest of your life.
well,
But
we should make this a part two.
We should
yeah,
definitely make it a part two. We've done the introduction now. We can get further into the weeds.
Yeah.
Right. Thank you. Bye, guys.
okay.
All right.
Thank you,
Bye-bye,
George.
George.
Thank you very much.